The video on chapter 8. And at the very end, we had a few problems in the first video. And one of them was on this problem, trying to figure out how the t-distribution works, which frankly I've never actually used in Excel, so you saw me stumble through it. But then we confirmed how, when you use descriptive statistics, that you can actually get a two-tailed confidence interval very easily from descriptive statistics, which is a good thing to know. The next thing we stumbled and never solved was how to solve this problem when you're trying to calculate the sample size for proportions. Now we know that the problem we have, suppose a mobile phone company wants to determine the current percentage of customers age 50 plus who use text messaging on their cell phones. How many customers age 50 plus should the company survey in order to be 90% confident that the estimated sample proportion is within 3 percentage points, plus or minus 0.03, of the true population proportion of customers age 50 plus who use text messaging on their cell phones? Okay, we noted, oops, wrong thing again. Here, let's go back here. That when we look at this, we're going to look at a sample of this problem 814, and so we want 90% confidence interval, and we use CI for confidence interval. CI, we want, that means alpha equals 0.1. It means that alpha divided by 2 equals the above divided by 2, which is 0.05, which means the z factor, z value for that is, and we go here, where is alpha equal to 0.05, 1.645. We know the EBP, or the margin of error, is supposed to be 0.03. We don't know what P prime and Q prime are. We need that to calculate the standard deviation. I forgot that when you don't know, you estimate these at 0.5. Because when they're both 0.5, and I get P times P prime, Q prime, I'm going to get equals this times this. That will give me 0.25. If I make them anything else, if I make it 0.6 and 0.4, I get 24. If I make it anything else but 0.5 and 0.5, I get something less. So if we don't know what it is, we assume 50-50, which is a perfectly symmetrical binomial distribution. It's going to give me the largest standard deviation for an n. Okay? And what else do we know? We know that n equals, we're trying to find n. So if we go back to this and we look at our formula, we need z over 2, p squared times q squared, which we have, and EBT. So this is going to be the square root of that. So we're just going to take the, rather than square it, it becomes the z squared and EBP squared and times this. So what do we get here? So if we get our n, and really it's going to be greater than or equal to, it's going to be equal to the z value times, and we're going to square that, divided by this EBP squared, which is going to be a very small number, and we're going to multiply that by this. And we're going to get 751 is going to be our sample size. So it has to be greater than that. So it has to be 752 is the answer to this thing. And I'm sorry I didn't make it bigger so you could see what we're doing. I'll post this short video and this Excel sheet in the Canvas. Thank you very much.